Hi, my name is Sury A. This is my project for PCHS, and today's topic is going to be Intro to the Pythagorean Trig Identity. So it's pretty obvious that I have a right triangle here, and I have its legs labeled as B and A, and C is the hypotenuse. So when it comes to triangles, we should be familiar with the Pythagorean theorem, which is A squared plus B squared equals C squared. And I'm going to very quickly put a theta here so we are able to identify what we know as SOA, Ka, and Toa. So I'm going to just scroll it down, and you may be wondering, like, what is the tie between SOHCAHTOA and the Pythagorean theorem? Like, what does that have to do with anything? So very quickly, we're going to go over our sign for this triangle, which would be opposite, because the O, and opposite from our theta is going to be B, and our hypotenuse is C. So then we're going to just quickly look at another example such as cos, and our adjacent of the theta, which would be here straight, is A, once again over the hypotenuse, which is C. So how would we get SOHCAHTOA to align with our Pythagorean theorem? So easily what we could do, once again changing colors, easily what we could do is simply square our sine and our cos. And if they were to become squared, so would our variables. So we have b squared, c squared, oh, that does not look like c squared, and then we have a squared and c squared. So knowing that our sine and cos can also be squared like our Pythagorean theorem, we are able to connect them when trying to set them equal to C initially. Like if we were to want to add them, for example, right? So once again, let's just change color so we know it's something different. So let's say now we're looking at sine squared plus cos squared. Like, where is that going to get us? That's the main point here. Like, what is that going to do? How is it going to help us find something new, something about this triangle? So as we already stated before, we know that this would initially equal b squared over c squared, over c squared, over c squared plus our a squared over c squared yet again. And since we have that common denominator, we're going to keep c squared as c squared, but our a and b are going to be like this. So it's going to be b squared plus a squared. But we know from our Pythagorean theorem up here that b squared plus a squared is actually just going to be, let's change colors again, let's go with this color. It's just going to be c squared over c squared. And initially, that comes out to just being 1. The importance of this is to understand that by figuring out something as simple as our sine and our cos from a triangle like this, and acknowledging that we know the Pythagorean theorem, it will allow us to find the sine and cos and tangent of any type of triangle that we would like to work with. So quickly, I just want to like put a simple, really simple example. So let's say instead our triangle actually had some numbers. So I'm just going to quickly do the rectangle that everyone knows, which is a 4, 3, 5. It's a very common triangle. So based on this, right, we could prove that these lengths are correct by using the Pythagorean theorem. So we have 4 squared plus 3 squared equals 5 squared. So 4 squared is 16, and 3 squared is 9, and that gets us 25. And our 5 squared over here is also 25. So we know that it is equal to each other. And let's say we didn't know our, don't know how that got there. Let's say we don't know our, actually we're going to use a different color to indicate this. But let's say we weren't to know our hypotenuse, right? So we have 4 squared plus 3 squared equals c squared. And now we're going to do 16 plus 9 equals c squared, which is simply 25 equals c squared. And what you would do here is you would just radical, so then you get 5 equals c. And that would be our hypotenuse. So it's just important to understand the connection between our Pythagorean theorem with our SOHCAHTOA and knowing how to find out the sides, because that's initially what will help you find out anything and everything about your right triangle or triangle that you're looking at. Thank you so much for listening, and I hope you learned something new today.